Welcome to iCarly. Welcome to my channel. Make sure you leave your likes and subscribes. Oh, what's smash that bell? What's the other one?
Got that like button.
There you go. All right. So once we get done with the lesson, if there's questions on last night's homework, then we'll answer those. I just want to make sure I get through this one, because then that gives a little bit more time to do some review type stuff. And I think we have one more section before we're done with this second half of chapter 1. So, yay. 1.9, section 1.9. So, section 1.8 is going to be on inverse functions. Inverse functions. And by the end, hopefully you'll be able to verify inverse functions, find an inverse function, use the horizontal line test to see if it has an inverse function, use the graph of a one-to-one function to graph its inverse function, and then find the inverse of a function and graph both functions on the same axis. So we're going to throw some functions in your function so you can make some functions while you're trying to function. An error occurred. Hopefully it's working, it's streaming. If it doesn't, then you know why. An error occurred. ¿Qué pasó? That's like my worst nightmare. Like, and my fly is down. Right?
I'm so sorry. I really like that.
Oh, I'm gonna tell you what. My brother went to the bathroom. He's in first grade, right? So he's trying to.
Hold that thought. Let's get here because it's recording. No, we're recording teacher too. Yes, YouTube. We just said that like 2 minutes ago. Like, leave your likes and subscribe, right? All right, here we go. So definition. That's all, folks. Here's your definition for inverse functions. I want you to notice this little terminology here. It looks like that. That is not f to the negative first power. Okay? That just means that that's the inverse function. Okay? What's really nice about taking a function and multiplying it by its inverse, you should get back a linear function. Just the original straight up mother function for a line. Okay? But here's your definition. Let's take a look at this fanciness. Let f and g be two functions such that f of g of x is equal to x for every x in the domain of g, and g of f of x is also equal to x, because obviously they are inverses of each other for every x in the domain of f of x. The function g is the inverse of function f, as denoted by the notation f inverse. F inverse. Looks like f to the negative first power. It's read f inverse. Oh, there it is. Yay, f inverse. And it just repeats exactly what we just said, okay? You guys cool with that?
Yep.
Change your slide?
Yeah.
Let's take a look. Yeah. Okay. Show that each function is the inverse of the other. So we want to verify. So here's the process. You guys still remember the process from last year?
No.
Okay. I'm going to first start by changing that f of x into a y. And then step 2 is I'm going to swap x and y. So x is equal to 4y minus 7. And then I solve it for y again. And then I solve it for y again. So I'm going to add 7 to both sides. Gone. That gives me x plus 7 is equal to 4y. And once I divide both sides by 4, I see that y is equal to x plus 7 over 4, which is what they gave us. Therefore, it is verified that they are inverses of each other.
We would only have to do one way in the show, right?
Technically, because once you get there, you should get the other one. Oh, I forgot something, didn't I? Well, not really. We good? 3 snaps and deep formation. We all giggly back there today. Is it the weather?
Yes.
I love, man, this weather makes me so sleepy and lazy. I'll say first, I want to be home, drinking hot chocolate and playing God of War.
This is the kind of book that makes you feel euphoric and want to do like crazy things.
In my pajamas.
Like what?
Can I change the slide? Moving on. There's your method one more time. If you want to see it in writing, I think everybody's memory was jogged, right?
Yes.
Jogged? Is that how you said it?
Yeah. Yeah, you jog your memory. Munoz. Those paper at you.
Not that athletic. All right, you try. Find me the inverse of this, please. Give you guys a minute, and then we're going to call somebody. Yeah. You, boy. Oh, this whole thing changed. Yeah. Oh, yeah. Check out those monsters. Because he's from Target.
I'm confused on what I just did.
No. I don't like the way I see your name. You know how much willpower it takes not to say your name that way? A lot.
Y equals Y. Once.
I got, I don't know what I got.
Y is equal to x minus 7.
5, 4, 3, 2,
That's exactly
1.
right.
Got it.
And the question goes to
Mixa.
Gabby.
Oh, Gabby?
And I already gave you your points. You got to give me the answer. Tell me what your inverse is. Try again. Give me your inverse. From the beginning. From the beginning.
Y equals x minus 7 over 2. Or is this?
Start with your function notation, bro.
She's giving you the, yeah.
He wants you to pretty much explain it all.
f of x is equal to x minus 7.
F inverse of x
Oh yeah.
is.
X minus
I'm just being picky. Go ahead.
X minus 7 over 2.
X minus 7 over 2. Yeah? Can I get a second and a third?
Second.
Oh, I got. I'm going to say I. Good. Let's move on. Let's not spend more time here. Okay. The horizontal line test for inverse functions. If a line can pass the horizontal line test, then it has an inverse. Simple enough?
Yeah.
Okay. You guys remember the vertical line, right?
Yes.
What was the vertical line test?
Determine if it's a function.
You cannot cross.
Same point. Same x value.
You can't cross the same.
Y.
Actually, that's not right, huh? You can't cross on the same x. You can't cross two y's.
Yeah.
Okay. Same idea, but with a horizontal. You can't cross two x's on the same y. Otherwise, when you find its inverse, it would not be a function. Okay. So, see how here we cross twice? That means that absolute value does not have an inverse function. We would have to limit its domain in order for it to have an inverse.
Wouldn't it be?
Okay? Let me repeat that.
It can only cross once.
It should only cross once, like over here. So this guy has an inverse. This guy does not. Unless we limit the domain on it, then we can find an inverse. But typically we will do that later on with trig. Okay? We'll limit domains. Yeah, boss. Yeah. Or you can wait in the back till the bell rings.
I mean, we're pretty much already almost done. What are we talking about?
Okay, yeah, we're almost pretty much done.
Could have just said that.
Or not. Okay.
Like, you get it.
Questions on the horizontal test?
No.
Pretty simple, yeah? We like that. All right, cool. Moving on.
I like simple.
That way.
Graphs of f and f inverse. they will be a reflection across the line y equals x. They will be a reflection across the line y equals x. Okay? So if you remember that from last year, so if I had something that looked like this maybe, then the other one should look something like, is that right? Does this look right? Yeah. Oh. Here it's a little steeper than it should, but you get the idea, right?
Yeah.
Where you are a reflection across this. Okay? And that should make sense because what do you do with all the x's and y's? You're swapping them. That's all you're really doing. You're swapping them. So, sometimes you get some really cool ones. That inverses?
Yeah.
I think so.
It looks like a D&D.
Moving on. Use the graph of f to draw its inverse. Okay. See the symmetry?
Yeah, I mean, actually, you're over there a little bit.
It's kind of hard to see it when they're separated, huh? I was like, what? But once you move it over, you can see that they are. And that's all you're really doing. So if you can find some critical points, like, just take those coordinates and what are you going to do with x's and y's? Swap them. And that'll produce the inverse image. Okay? Cool, cool, cool? Questions? Yeah. Moving on?
Can we have our homework now?
Please, sir, can I